Hello, my name is Naomi Pineda, and today I will be presenting on harnessing silver nanoparticles for eco-friendly dye degradation. Today we will examine the study, green synthesis, characterization, and photoanalytic application of silver nanoparticles synthesized by various plant extracts. The primary issue addressed in this study is the environmental pollution resulting from the discharge of dyes and chemicals into our natural water and bodies and land. In this study, their objective was to develop an efficient and eco-friendly method for removing dyes from contaminated water through the use of silver nanoparticles synthesized with plant extracts. Now, let's take a closer look at the consequences of dye discharge on our environment and health. Dye and chemical effluents, when released into our natural water bodies and land, contribute significantly to elevated pollution levels. This pollution, in turn, has far-reaching consequences for our ecosystems. The persistence of these dyes can disrupt the natural balance and biodiversity of our rivers, lakes, and surrounding land areas. Beyond its impact on ecosystems, dye-contaminated water sources also pose direct health risks to humans. Consuming or using water tainted with these pollutants can have adverse effects on our well-being. Now let's examine the limitations of traditional approaches when it comes to tackling dye pollution. Firstly, conventional methods struggle when it comes to dealing with the persistence of dye compounds in effluents. These persistent dyes can be challenging to completely remove. Moreover, these methods often fall short in efficiently breaking down dye molecules, leaving behind residual pollutants that continue to impact the environment. This ineffectiveness in dye removal carries significant consequences, including increased environmental pollution and the potential for harm to ecosystems and human health. Now let's delve into the study's primary goal and the rationale behind it. The study had a clear objective: to develop a more advanced and efficient method for removing dyes from contaminated water sources. The rationale behind this objective lies in the limitations of conventional dye removal methods. These traditional approaches often fall short, prompting the study to explore an innovative solution. The researchers considered the use of silver nanoparticles synthesized with plant extracts as a potential superior alternative for dye removal. Now, let's discuss how silver nanoparticles offer a promising solution in the context of our study. Silver nanoparticles hold great promise as a potential solution to address the issue of dye contamination in our environment. Specifically, silver nanoparticles can play a crucial role in environmental remediation by catalytically breaking down dye compounds present in contaminated water. This approach is not only efficient but also more sustainable, offering a promising alternative to conventional methods. Now let's take a look into the eco-friendly approach used in the synthesis of silver nanoparticles in this study, which I think is the most important part of this presentation. One of the standout features of this study is the eco-conscious approach to silver nanoparticle synthesis. Researchers utilized extracts from plants like onion, tomato, and acacia catechu. Unlike conventional methods that often rely on toxic chemicals, this eco-friendly approach eliminates their use entirely. This not only reduces the environmental impact, but also ensures a safer process. Additionally, the use of plant extracts proves to be cost-effective, making this method accessible to a wide range of industries and even economically challenged regions. Now let's explore the materials and methods employed in this study for the synthesis of silver nanoparticles. The study utilized various materials including fresh onion, tomato, and acacia catechu powder, along with essential chemicals such as silver nitrate, ethanol, sodium borohydrate, and the target dyes, which are methyl orange, methyl red, and Congo red, which are MO, MR, and CR. Additionally, glassware and distilled water were essential components throughout the study. To begin, researchers prepared plant extracts by cutting onion and tomato, followed by thorough washing with distilled water. These plant materials, along with the cassava tissue, were then mixed with distilled water. Afterward, the mixtures were heated to boiling for 20 minutes to obtain an aqueous extract. Following cooling process, the combinations were filtered through a Wattman filter paper and preserved at a temperature of 40 degrees Celsius for subsequent utilization. The synthesis of silver nanoparticles, or AGNPS, was achieved by preparing a 1 millimolar silver nitrate solution. This solution was then mixed with the previous prepared plant extracts, stirred and left at room temperature for 24 hours. The changing color of the solution from white to light brown and finally to dark brown indicated the formation of silver nanoparticles. After synthesis, the nanoparticles were purified by centrifugation, washed with ethanol and distilled water, and then dried in a vacuum oven at 70 degrees Celsius for 12 hours. Now let's take a look at the analytical techniques used for the characterization of silver nanoparticles. So one of them was the UV-vis absorption spectroscopy was employed to measure absorption spectra, allowing us to identify unique properties of silver nanoparticles. X-ray diffraction was utilized to investigate the crystal structure of the silver nanoparticles and to detect any impurities present. FTIR spectroscopy played a crucial role in identifying the functional groups responsible for the formation of silver nanoparticles. DLS analysis was used to analyze the particle size distribution of the silver nanoparticles, providing valuable insights into their characteristics. SEM allowed for the examination of particle size and morphology, offering a detailed view of the silver nanoparticles' physical attributes. Finally, TEM was employed to provide comprehensive information about the size and shape of the silver nanoparticles. Now let's explore the catalytic experiments conducted in this study to assess the efficiency of silver nanoparticles in dye degradation. The study focused on 3 specific dyes: methyl orange, or MO, methyl red, or MR, and Congo red, or CR, chosen for their relevance in dye pollution. Control sets were included consisting of pure dye samples without the presence of silver nanoparticles. These served as a reference points for comparison. The procedure involved the introduction of silver nanoparticles into the dye solutions, followed by the monitoring of degradation using the UV-vis spectroscopy. Reaction times were measured to determine the duration required for complete degradation. The results of all of the experiments demonstrated the efficiency of silver nanoparticles in rapidly breaking down the selected dyes. Additionally, the study compared silver nanoparticles synthesized with different extracts with a particular emphasis on the enhanced performance observed when using the combined COT extract. Now let's dive into the key findings of the study regarding the effectiveness of silver nanoparticles in dye degradation. The study demonstrated that silver nanoparticles effectively degraded the selected dyes of methyl orange, MO, methyl red, MR, and Congo red, which is CR. Notably, this degradation was rapid and complete, achieved within a matter of minutes. In a comparative analysis, the study examined silver nanoparticles synthesized from single extracts and those synthesized using the combined COT extract. The results showed that silver nanoparticles derived from the combined COT extract exhibited superior efficiency in dye degradation. These findings have significant implications indicating that silver nanoparticles hold promise as highly efficient method for removing dyes in environmental remediation. Now let's explore the efficiency comparison of silver nanoparticles synthesized from different extracts and their implications. In this study, researchers compared silver nanoparticles synthesized from various plant extracts. Notably, they highlighted the superior performance of silver nanoparticles synthesized with the combined COT extract. It is worth mentioning that silver nanoparticles synthesized from single extracts such as onion and acacia catechu were already efficient in dye degradation. They achieved complete degradation in relatively short times, which was 15 to 20 minutes. However, the COT extract synthesized silver nanoparticles outperformed the others, achieving even faster and more efficient dye degradation. These findings underscore the superiority of the combined COT extract in enhancing silver nanoparticle synthesis and also significantly improving dye removal efficiency. Now let's explore the potential applications and the associated benefits of using silver nanoparticles for efficient dye removal. Silver nanoparticles offer a wide range of applications. They can effectively treat effluents in industries such as textiles, paper manufacturing, plastics, and chemical production. By rapidly removing dyes, silver nanoparticles play a pivotal role in addressing environmental pollution. This leads to a cleaner water resources and reduces the impact on ecosystems. This approach exemplifies sustainable nanotechnology by eliminating the need for toxic chemicals and utilizing natural extracts. Additionally, the cost-effectiveness of this method makes it accessible to a broader range of industries, including economically challenged regions. The elimination of toxic chemicals in the synthesis process also means reduced health risk for workers involved in silver nanoparticles production, emphasizing the importance of occupational health and safety. Beyond dye removal, silver nanoparticles open up opportunities in nanomedicine and catalysis, offering innovative solutions for various fields. The green synthesis approach adopted in this study eliminated the use of toxic chemicals, paving the way for a responsible pathway in nanomaterial production. This eco-conscious approach aligns perfectly with the principles of environmental preservation. From a health perspective, the use of green synthesis ensures safer working conditions for those involved in nanoparticle production. This approach prioritizes occupational health and safety, significantly reducing health risk for workers. Now let's explore the diverse applications of silver nanoparticles beyond dye degradation and the innovation opportunities that they present. Silver nanoparticles exhibit catalytic properties that extend beyond dye degradation. They hold potential applications in diverse fields, including wastewater treatment, nanomedicine, and catalysis. This opens up new avenues for technological development and innovation. These advanced applications have the potential for broader societal impacts, shaping the future of various industries. Let's summarize the main findings in this study and discuss their implications, particularly in the context of environmental responsibility. The study revealed that silver nanoparticles are highly effective in removing dyes, with particularly impressive results when synthesized with the combined COT extract. This approach offers an eco-friendly and cost-effective solution for addressing dye pollution. These findings have significant implications. They led to cleaner water, promote sustainability, and offer economic benefits. Moreover, they emphasize the importance of responsible practices in various industries. Environmental responsibility is vital for addressing global environmental concerns. This study sets a sustainable industry precedent by showcasing the potential of eco-friendly silver nanoparticles in mitigating environmental pollution. To conclude our presentation, let's discuss a teaching strategy and key takeaways for students. When teaching this material, encourage engaging discussions amongst students on dye pollution's environmental impact. You can also consider performing a hands-on silver nanoparticle synthesis if possible, or use visuals to illustrate characterization techniques. Some discussion points to explore with students include understanding the effects of nanoparticles on the environment and analyzing the benefits of eco-friendly silver nanoparticle synthesis and sustainability. Promote critical thinking by encouraging students to discuss real-world applications of silver nanoparticles and ethical considerations related to their use. In conclusion, emphasize the importance of sustainability, the potential of silver nanoparticles in addressing environmental challenges, and the need for critical thinking in today's world. Now, this concludes my presentation, and here is a list of my references. Thank you so much for listening.